Hey guys, my name is Jason with Baker Mining and Metals, and on today's video, we're going to be running some electronic circuit boards through this hammer mill and shaker table behind me to recover the metals, and then we'll smelt them down and get them analyzed. Alright, we'll do a quick walkthrough here. This is one of our 16 by 12 inch hammer mills, and it has some hammers in there that spin around in the case, and all the way wrapped around the bottom 180 degrees is a screen that has a 1 millimeter laser cut slot in it that's about an inch long, and the whole screen is covered in those slots. And I feed the material in here, falls down, gets beat up, crushed through the screen. We mix it with water and comes down here onto the shaker table, where all the metals, the dense metals, will come across these grooves up under the water bar and down into the number 1 and number 2 concentrates. The lighter metals like the aluminum and some of the epoxy and stuff is going to come down here into the number 3 middlings. And then the very light plastic and the fiberboard and glass insulation, or the glass fibers, are going to come down here into our settling pond. We've got a water pump over here that feeds the shaker table. We've got a water pump here that feeds into the hammer mill. And we just keep recirculating the water over and over again so there's no discharge to the environment or to waste. All right, we'll take a look at some of these boards. I'm not a board guy, I'll be the first to tell you. So I don't know if these are good, bad, worth a lot of money, not worth a lot of money. We're just going to grind them all up and get the metals out. But you guys tell me, are there some good boards in here? Is this mid-grade? You know, is this something that you guys would get excited about? I don't even know how old these boards are. That one looks pretty old. But I'll grab a couple buckets full of this stuff and we'll run it through the system. Oh, here's one I found that looks pretty good. I don't know, it's got a lot of those little black chips on it and stuff. So we'll throw that in the mix. And with the 16 by 12, it'll take anything you can fit down the throat of the machine. But some of these bigger boards like this one, we would pre-shred through one of our larger hammer mills through like a 1-inch slotted screen, crush it up, and it would actually look something like this. And then you take this material and run it through our small hammer mill on the shaker table. But I got my 2 buckets here. We'll go get them weighed, figure out how much our feedstock weighs, and then we can do kind of a little percent recovery thing on them. All right, well, I got these weighed up. They weigh 15 pounds between the two of them, 15.5 pounds actually, which is not a whole lot of material, but these are usually, on our past experiments, have been about 30% metal by weight. So we're expecting somewhere around 5 pounds of metal out of this stuff, which will get smelted down and analyzed. This thing is run by this 3-phase generator here. So the hammer mills are 3-phase. And we have that little box right there is a VFD that can control the flow of water into the hammer mill. So let me get the generator going and we'll start feeding material into the hammer mill. Okay, here is our stuff from the 15.5 pounds of boards we ran. Here's the number 1. And most of the gold pins are in there. Any gold pins we had are in there. And there's a little band of real dark gray stuff on the table. I don't know if you can see it in the camera, but I think it's lead or tin. And then this is the number 2, which has more material and it weighs a lot more, but it's mostly just copper. There's a few pins in there and stuff, but it's mostly just flakes of copper. Maybe a little bit of aluminum in there as well. And then here is what we're going to call the number 3, which is probably, it's mostly fiberglass. There's a little bit, if you look right in the middle, right where the thing drops the stuff out, there's a little bit of copper in there, but not much. And then the 4 just went into the tub. The tailings, the true tailings, just went into the tub there. And it's real fine stuff, all the plastic that floats. That's probably, there's hardly any copper in there. If there's enough, you might want to run it again or get a longer splitter there on the table and make a better cut between the copper and the fiberglass. So most of this fiberglass and plastic can go in the tailings and the waste. Well, let's get this stuff weighed, and then I'll melt down the number 1 and the number 2 separate probably, and we'll get them zapped to the XRF gun. Here's our stuff kind of drying out on some cookie sheets. This is the number 1 from the 15.5 pounds. This is the number 2. So we'll let that dry out, and then we'll get it smelted down. Okay, here is the metal that came off the number 1 on this side and number 2 on this side from all that miscellaneous junk we had sitting around. And you can see, kind of, most of the gold-plated stuff is in here in the number 1. Still a lot of copper wire. Here's another bucket of number 1. The interesting thing, and I couldn't say it when I was taking the video, is the amount of material that was coming over into the number 1 varied. And it didn't seem to vary with the amount of material on the table. It seemed to vary with the characteristics. So if there's a lot more gold pins and some of these larger gold or copper wires and stuff, it would flood over into the number 1 and make a really wide band. It'd be 2 or 3 inches wide. Here's the number 2 stuff. And if there wasn't a lot of that stuff, at one point when I first started running, there was a lot of little copper, like flakes and discs and stuff. A lot of it went in here. But then a lot of it went down to the number 3 concentrates as well. So this is all number 2 you're looking at here. And that surprised me. I always thought that it really didn't matter how much material was on the table. Only so much could go over into the number 1. But that's not true. It depends on the characteristics. So if you have a lot of flat, flaky, disc-shaped copper pieces, they'll go into the number 2 and the number 3, and hardly anything will go over into the number 1. And then if you have a lot more gold pins and coarser pieces of copper, they'll end up over in the number 1 and won't go down to number 2 and number 3. Moving over here, here's a look at the number 3. And there's 2 different kind of samples here. It was hard because when I was running it, the amount of material on the table kind of determined where the splitter went, and I need to make a longer splitter for this table. But so I got some junk in here with the number 3, but this bucket is mostly copper by weight, and a lot of it is those little discs I was talking about. And it's just real flat, flaky stuff. I think it's the copper between the laminated fiberglass boards. And then this is the same stuff, but this is when there wasn't nearly as much copper on the table. And it's mostly fiberglass and plastic. So there's not a lot of copper in here. So, and again, with a splitter that's a little bit longer, so I could make the cut farther towards the number 1 and number 2 hole. I could make a better cut, and also with a consistent feed on the shaker table, which I wasn't getting, would help. So if you can make it consistent, and the copper and the plastic line of separation is here, with a longer splitter, you could bring that all the way over. And if it's consistent, you can just cut it there and get a real nice cut between the number 3 and the number 4. My problem is my splitter isn't long enough. And if I move it over, all this stuff runs back downhill into the number 3. So that's as close as I can cut it right now. But I'll just make a longer one of those to get a little bit better separation. But yeah, so we got all that junk cleaned up. I'll get it all kind of laid out to dry. All right, here's the material from all those miscellaneous junk, essentially, that I ran. Here's the number 1 in the back. Here's the number 2. That'll take a couple days to dry out, but we'll get that all dried out, get it weighed, and then we'll smelt some of it down and get it analyzed. Okay, guys, it's been a day. The stuff is dried out just sitting here. I was kind of playing around with it. It's kind of rusted together a little bit, so I was just scraping it off here. But I think it's all pretty well dried out, so we'll get it loaded up into some crucibles and melt it down. All right, here's the number 1 cons. And the weight on that is just about 2 pounds. All right, guys, here's a real quick view of my setup. I got a propane tank and a shop vac as a blower. They come down here into this hose and mix. Burner into a KO wool furnace. And I've got a crucible down there that is actually stuck to the bottom of the bricks. But I'll put our material in that crucible, and when it warms up, we can pull it out of there and pour it. All right, we've got our stuff loaded in that crucible, and I've been debating with myself about whether I'm going to use any flux or not. So the first one here with the number 1, I'm going to try with no flux and see if I can get it to melt down. There may be a bunch of junk on top we have to scrape off, but and if it doesn't work, I can always add some borax to the top of this to get some of those oxides, some of that junk off the top. So we'll get her fired up here and see what happens. All right, guys, here's our number 1. Again, I've remelted this down the second time to try and get a better melt out of it. Let's see what happens here. Yeah, that looks better. Let's knock on it with a hammer here a little bit. All right, YouTube, here's my problem. Somebody help me solve this. So here is the number 1 stuff, the high-grade concentrates. I melted them down once, added borax to try and get all the oxides soaked up, and it looked a lot like this one, where it was all gnarly on top. When I poured it, there was clearly liquid metal, but then a bunch of kind of foamy, dense junk came out on top, made all this kind of nasty-looking pitted stuff there on top. It didn't all collect down in a nice cone. So then I took it again and remelted it, just the metal and a little bit of slag that was still attached to it. I got a better melt. I mean, it's more flat on top, but it's still kind of pockmarked. When I poured it, there was still some stuff. It's like it's slag or I don't know what it is, but it's got really dense stuff in it, so it kind of settles in with the block of metal. So who can tell me how to melt down all these computer parts, all the metal from these computer parts, and get a really nice, good melt where I have a nice separation of slag, metal, the slag breaks off real nice from the metal pyramid. This is the number 2 that I only melted 1 time, and it's got this gnarly kind of stuff on top. One thing I might try, I'll go get these XRF'd and we'll see what's in them. I'm going to grind a little flat spot. It's hot. I'm going to grind a little flat spot on there so we can expose some fresh metal. And I'll get both these XRF'd and we'll see what's in them. But then I've got one more thing I might come back and try. I might try in-cording with lead, actually. I might have a melting point problem, whatever alloy this is. I can't quite reach the melting point. So I may come back and try and put them both together in a crucible and add, I don't know, a pound of lead maybe, and see if I can, with adding lead, get the melting point of the alloy reduced, and then hopefully get a nice separation between the slag and the metal. But let's go get them XRF'd and see what they look like. Okay, one more thing here before we get them zapped. This was the number one. I had right about 2 pounds of number one. And we've got about 1 3/4 pound now. So I lost a little bit. Maybe there's a little bit of junk in there. Some of the oxides got absorbed. Here's the number two. We ended up with 4 pounds of number two total. I only smelted about a pound because that's all I could fit in the crucible, and then I wasn't getting good pours, but we ended up with a little bit less, 2 ounces less than a pound of there. So I lost a little bit in both, but not much. And altogether, the number one weighed 2 pounds. The number two altogether weighed 4 pounds. So grand total, we got 6 pounds of concentrates in the number one and number two out of 15.5 pounds of boards. All right, guys. Well, judging by the XRF's gun reading, we got mostly copper, which I can melt in my furnace, but there might be enough iron and nickel in there that it raises the melting point of that alloy, and we can't get a good melt out of it. So I'm just going to try. I've got a pound of lead, miscellaneous lead stuff here weighed out. I'm going to try and remelt both these together, and I'm going to add that pound of lead and just see what happens. See if I can get a good melt and get it poured in our cone mold and see if we can get good separation and a nice flat top and see if we can get it all melted down. So we'll try that now. All right, guys, let me catch you up to speed here. So this is the number one and number two that I in-quarted with lead. Got it up to about 2250 degrees Fahrenheit. That's as hot as I could get in my furnace. I let it sit with a little bit of borax on top, and it just bubbled and bubbled and bubbled and bubbled. So finally I poured it, got it in my cone mold, and man, it just stuck to the sides like crazy. I think all the lead fused with the steel at that high temperature, and it was a real bear to get it out. I'm not quite sure what I'm going to do with this thing now. So we got this out. It still poured kind of real junky, and there was definitely some stuff in there that wasn't molten. So what I did is I took some of the number two we had left over here, and I pulled out all the magnetics. So this is the magnetic fraction. And I just used a cow magnet, pulled out all the magnetics. The interesting part to me is it's not visibly real obvious that it's magnetic. A lot of it still has copper in it or copper looking stuff. But this is all the magnetics. I went over it 2 or 3 times, and this is the stuff the magnet pulled out. Right now in the furnace, I have the non-magnetics from the number 2. And my theory is, let me pop this open so you can see. My theory is that the bubbles we're seeing is the zinc. It's the zinc boiling essentially and going into the gas phase. It's still going there a little bit. So I think that's the zinc coming off because it gets past the zinc boiling point. Because I don't have a cone mold right now, I don't want to pour this in the cone mold. I'm just going to let it cool down slowly in the crucible. I'm going to sacrifice that crucible and then break it out of there. And I stirred it a couple different times with my steel rod. And unlike this one here, it doesn't feel like it has a lot of stuff that's not melted in it. The stuff in the furnace right now seems like it's pretty liquid. So we're going to let that cool down. Once it's below about 1,000 degrees Fahrenheit, I'm going to pull it out of there and let it sit, and then we'll break it open and see what we got. Well, it's stuck to the bottom on that brick, which is irritating. Kind of how the whole day's been going. But we'll let that cool down. You can take a look. It's still bubbling just a little bit. But we'll let that cool down, and I'll just bust it open with a hammer and see what the metal looks like there. All right, guys, well, we're about 700 degrees Fahrenheit in the middle. It's a little warmer than I like to be, but I'm tired of waiting. So first thing is I got to get it knocked off that brick, and then we'll bust her open. Okay, let's see how this goes here. So I'm just going to... There we go. That wasn't too bad. Now, let me get my hammer here. Well, that worked pretty good. Whew, hot. Oh. It's still gooey in the middle. Ugh. But this is what we're after. Oh, that's also hot. So let me get that dunked in some water and cooled down. So there you go. That's the top side. There's the bottom side. It's still all pockmarked and nasty looking, but it is what it is. It's separated from the slag nice, which is a plus. We were looking for that, so that worked well. All right, guys. So help me out. How do I crack this nut? This is the $1 million question. What do you do with all the metal that comes off the shaker table when you're running boards? Do you send it off as it is to a refiner? Do you try and figure out how to smelt it like I was doing today? If that's the route we want to take, how do I do that? Do I pre-wash it with some sort of HCl solution and try and get the iron and the zinc out? Do I in-quart it with lead? I mean, I'm out here just kind of trying stuff. And as you can see behind me there, I've got these 1 and 2 pans full of material ready to go. So if you guys can help me crack this nut, I'd be much appreciated. So please share your advice and your ideas in the comment section below. And I'll do another video here when I got a good idea on how to proceed. So thanks again for watching, and we'll see you on the next video.